For our self-built camp trailer, I wanted to maximize solar collection for the least amount of money. Let me show you how I did it. This video is the first of several videos that will walk through different portions of the electrical design in the camp trailer that we built and travel in full time. Today, I'll begin with a high-level overview of the whole system, then do a deep dive into just the solar portion. By walking through the design, I hope you get a better understanding of the factors that affect the performance of a solar system and a better feel for the design process. The trailer electrical system is completely independent from the van, so it has all the elements necessary for an off-grid system. This includes power collection, storage, and distribution out to everything that uses power. We can collect power from the power grid by plugging into a 15 or 30 amp circuit, but nearly 100% of the power we use comes from the sun. Solar panels convert light energy to electrical energy, then a solar charge controller converts that into a voltage and current needed to charge the battery bank and power DC appliances. As I've mentioned in other videos, I've had an interest in solar energy for a long time, and I was really excited that finally I had a good excuse to put a system together. For the trailer, my first design priority was to maximize solar power capacity, but coming in a close second was minimizing the electrical system cost. So this build was an exercise in designing to the point of diminishing returns, or the knee in the value curve. This is the point where you can spend more money, but it only adds marginal performance improvement. The electrical system has a big impact on the quality of life and can be a major portion of the cost. So I went a little further analyzing the design, both to save myself some money and to provide examples of how to stretch a limited budget. The first step to maximizing solar collection was understanding what the limiting factor is. Normally this would be the budget, but because it was important to me, I decided to save up so that cost wouldn't be a limitation. So for me and most other mobile applications, the next limiting factor is available space on the roof. Yes, there are solar panels that you can prop up on the ground when you get to a campsite. These are a great solution for anyone without a built-in solution or severely limited roof space, but it isn't a good fit for me. Since I don't have any space to store them, I'd have to find some place to strap them down in the living space while we travel. This would end up being the worst when we're urban camping and it's not possible to put them outside. So with space as a limiting factor, there are two design controls available to maximize solar collection. First is figuring out how to maximize the use of available space, and second is finding panels that squeeze the most power from every square inch. To optimize use of available space, I created a scale model of the trailer roof and all the stuff that goes up there to test fit different solar panel sizes and configurations. I used a mechanical CAD tool, Fusion 360, because it's a free tool that I was familiar with. But I'll show you how to do it with Inkscape, another free tool that's just as good at this task and has a shorter learning curve. This is where you can pick it up. It's inkscape.org, and then you can go to the download tab here and pick up the current version. I don't think I have the current version, but that's okay. So I'm going to go ahead and open up Inkscape. And the first thing I'm going to do is set the document size. That's the size of the page I'm going to be working on. So I'll go over here, File, Document Properties, and I'm going to change the units to inches because that makes sense to me. And then I will have an 84 for 7 feet wide by, 192, which will be 16 feet high. And then I'll go ahead and clear that. And then I can zoom in. I think the zoom page is this one here. Zoom to fit page. So now I've got a page that's the same size as my trailer, 7 feet wide by 16 feet long. And the next thing I'm going to do is create a block using this tool here to represent the trailer. So it picked a color that I used the last time around, and I'll show you can click on this window here or this little icon here, and that'll bring a color picker out so I can change. I basically select the selector tool, I pick this block, and then I can change the color of the block if I want. But I want to keep it lightweight, so I'm going to swing it around. We'll make it kind of yellow, and that's a little too bright. Maybe we'll put it right over here. Okay, so we'll pick that color for the trailer. Now I still have the selector tool on, and I'm going to set a few settings up at the top. So once this is selected, the bar up here is related to this particular element. I'm going to again select inches, and then I'm going to put the, alright, so the X and Y define where this lower corner is going to end up. So I'm going to set that at 0 and 0. And then I can define the size here. So I'm going to change that also to be 84 inches by 100 and what is it, 96? 192 inches. Okay, so now I have a block for the trailer that represents the roof of the trailer that perfectly fits on the page that I have defined. You'll notice on this particular one I'm not putting the little V shape in it because I don't intend to use that to take advantage of that particular space. So I'm just going to pay attention to the box portion of the trailer that I have available. Okay, the next thing I want to do is I have a couple antennas that I'm going to be putting on the roof, and I want to define a keep out space for those particular antennas. So I've chosen to define a space that is one wavelength of the wavelengths that the particular antennas work on. So one wavelength radius. I'll do that by coming over here and grabbing this circle tool, and I'll just create this circle anywhere. Now you can see it made it the same color, but I want to go ahead and change it to just anything else, so I'll pick something in the blue range. That's good enough there. And I have the selector tool, so now these things are defined to, these will define the shape here. So on the width, this is going to be the full width. So I care about the wavelength of a particular antenna. So for the WeBoost antenna, the lowest frequency that it's going to operate off of is 700 megahertz. And I've calculated out the wavelength for that. It ends up being 42.9 centimeters or 16.87 inches. So I'm going to take that, I'm going to assume 17. That's going to be the radius. So the full width, the full diameter needs to be 34 inches for this one. So I'm going to go ahead and make that, I got close here, make that 34 inches by 34. So now I have a circle that's the right dimension. Okay, so I'm going to make a label on this particular one so I don't forget what it is. So I'm going to pick the text tool, and now I'm going to come up here and select a big font because I'm working on such a large page. And I'll type in here, let me get out of that, and then I'm going to expand that. Okay, so that's the WeBoost. Last thing I'm going to do is select that object and group it so that now these two are stuck together when I move the thing around. So I will go ahead and create a few more items, basically using the same approach that I did with these first two. Okay, I came back because I'm now creating the solar panels, and I'm going to create a couple different sizes, but I want to show you how this is really pretty handy. You will find, I think, a lot of solar panels come, and the dimensions that they give are in millimeters. The nice thing about Inkscape is you can switch back and forth between units. So I just created this block here, and I've got the selector tool on right there. So I'm going to define the first one. So this is a 100 watt panel that's easily available, and I'm going to keep it in inches because that's how the manufacturer defined it. So the first dimension is 40 point, oops, what happened? Something happened. What am I doing? Am I high on drugs? What just occurred? So let me switch that around. I'm going to make that the width of 21. So it's 21 inches wide by 40.9 inches tall. Okay, so that's the first one of those. We'll go ahead and reselect the rectangle and define another one. So the width of the second one, this is going to be 175 watts. I'm going to switch the units to millimeters. This is 668 wide, 668 wide by 1326 long. Okay, so I have now defined 3 different solar panel sizes, 100, 175, and a 310 watt. And now, I've also grouped them so I can move both the text and the block by itself. Last thing, I also defined the little Wi-Fi antenna. So you can see the wavelength for Wi-Fi is 2.4 gigahertz, is much smaller than the 700 megahertz wavelength for the cell phones. So now what I can do is basically place these different elements on my roof and sort of move them around and see, you know, how do I want to fit these things together. One other thing I can do is highlight this guy and then copy, Control C, Control V, Control V, Control V. So I can make multiple elements of all of these devices. Okay, so now I've got, I can have different solar panels and create as many of them as I want. And I can start pulling them on here. Oh, and if I need to, I can also, with the selector tool, if you click a second time, you get different handles on these. So you can actually rotate them and try putting them sideways or up and down, right? So now I'll just kind of jump to the end here. So I know after working with this for some amount of time, I determined actually that 4 of these 310 watt solar panels work out pretty well on the corners of the trailer that I have. And oh, I left out, let me make it real quick. I left out the fan. Okay, so for my particular plan, you can see that I ended up with space for everything when I have 4 of the panels arrayed kind of at the corners of the trailer, and I have room for the fan and both of the antennas that I want to make space for. With panel size selected, the second control you have in a space-limited installation is selecting panels with the highest power output per area. I started by creating a spreadsheet with dimensions, power, and cost for several solar panels to determine how well each one generates power per square meter. Next, I created a chart with the things I care about on each axis. Power per area is on the horizontal axis, and the cost is on the vertical axis. The further to the right a panel is, the better it uses available space to produce power. The lower a point is on the graph, the cheaper it is per watt. So the direction of goodness on this graph is the lower right corner. The closer a panel lands in that direction, the better it meets my priorities. If it wasn't already obvious, when I have the spreadsheet plot a trend line, it's easy to see the sweet spot. That is, which panel is producing the most power before the cost starts to ramp up quickly. After deciding on the number and type of solar panels, the next step is selecting the charge controller. I started this first by figuring out how I would array these 4 solar panels together. The first possibility is to string them all together in series. In this case, the panel voltages are summed together and the total current is the same as a single panel. The upside is lower losses in the cable running to the solar charge controller, but the downside is that the voltage is too high for most charge controllers that work with a 12-volt battery bank. This configuration is also the most adversely affected by partial shade. They could also be connected in parallel, where the current from each panel is summed together and the voltage remains the same as a single panel. This configuration is the least impacted by partial shade, and in this specific case of an array and battery bank voltages, it would result in the highest efficiency for most of the charge controllers. The downside is that the wiring on the roof ends up more complex. I chose to split the difference and go with a series parallel configuration instead. In this case, the array has double the voltage and double the current of a single panel. This gave me many charge controllers to choose from and kept the wiring relatively simple. Converter operation is somewhat less efficient, and performance in partial shade lands between the parallel and the series configurations. So I hope you have a better feel for some of the factors that are under your control when you're building a solar system. There are several different size panels that you can consider to make best use of space you have available. There is also more than one way to decide on the right panel for you. If you're space limited like me, you can opt for more efficient panels or lower cost per watt if space isn't an issue. The panels can be arrayed to optimize charge controller operation, reduce the impact of shading, and reduce transmission losses in the cabling. If you've found this video valuable, please hit the subscribe button. And comment below if you have questions about the topics I covered in this video or any others you have about off-grid solar systems.